Hello my friends, in this video you will learn how to solve your disaster recovery needs with YugabyteDB. In particular, we will take a look at one of the deployment patterns. We will have two standalone YugabyteDB clusters that will be provisioned in different cloud regions. And then we will take advantage of the xCluster disaster recovery feature to configure the replication and to simplify switchover and the failover between those clusters. However, before we do the deep dive, my friend, I want to remind you that the pattern that we are going to explore is not the only one that is supported by YugabyteDB for your disaster recovery needs. In fact, if you go to the design patterns of the global applications with YugabyteDB, you will find an exhaustive list of several patterns that you can pick from for your multi-region deployments. And you pick those patterns based on your recovery point objective, recovery time objective, your latency requirements, and your data residency requirements. For instance, in this list you will find some of the typical patterns, some of the standard ones that we have already used with other databases. This active multi-master approach allows you to deploy two standalone YugabyteDB instances, and then every instance will be functioning in the read and write mode, and you have asynchronous replication between those two clusters. Also, among those patterns, you will find something that is unique to YugabyteDB. For instance, a geo-partition deployment. You deploy your geo-partition cluster and the database will be pinning user data to specific locations, and by doing that, you will be able to achieve the low latency across all of the locations, and you will be able to comply with the data regulatory requirements. In the description to this video, you will find the link to one of our upcoming tech talks. Join it, because during that talk, I will show you a lot of those patterns in practice. But today, for this particular video, I want us to focus on the active single master approach. Let's go to this page and quickly take a look at the following diagram. With this setup, we have two standalone YugabyteDB clusters, and each cluster is deployed in one of the cloud regions. One of the clusters is designated as the primary. Applications connect to this cluster by default, and the cluster serves all of the read and write workloads. The other cluster is located in different cloud locations, and that cluster serves as a secondary or a replica one. That secondary cluster receives all the changes from the primary synchronously. YugabyteDB supports the xCluster asynchronous replication. And even though there will be some data lag because we are using the asynchronous replication, the replication approach of YugabyteDB is fully transactional, meaning that the secondary cluster will be committing only those transactions that are fully received from the primary. Okay? And you can deploy this configuration by using the open source version of YugabyteDB. However, today I want us to explore the latest feature that was added to the YugabyteDB Anywhere. The name of this feature is xCluster Disaster Recovery. And if you don't know what YugabyteDB Anywhere is, YugabyteDB Anywhere is a database as a service that allows you to easily manage, deploy, and operate your YugabyteDB instances in your private data center, in your public cloud environment, or in your hybrid environments. So the beauty of the xCluster Disaster Recovery is that you just go to the YugabyteDB Anywhere interface, you select your primary cluster, you select your replica cluster, then the feature sets up their asynchronous replication, and whenever you need to do the failover or switchover between those clusters, then guess what? It will be straightforward to accomplish. So why don't we finally do this deep dive and see how this feature works in practice? Alright my friends, welcome to my YugabyteDB Anywhere deployment. And presently we are on the provider configuration screen, where you can set up an infrastructure that's going to be used for your YugabyteDB deployments. I will be using Microsoft Azure today. What I've already done, I created several regions that can be used for my YugabyteDB clusters. But if you prefer to run YugabyteDB in other public environment or private data centers, as you can see, YugabyteDB Anywhere supports various options. So now let's take a look at the universes. Under the universes, we mean standalone YugabyteDB clusters that already used the configuration that I created for Azure. One of them runs in the United States East, the second one runs in the United States West, and we will set up the xCluster DR between those clusters. We will test the multi-region outages, we will test the switchover and the failover, but I want us to take it slowly. And by meaning that, I want us to start with the primary cluster. Let's open it up. So this is our cluster in the United States East. If you go to the nodes tab, you will see that I have 3 nodes. The replication factor is 3, meaning that every node keeps a copy of your data. And what's cool is that every node runs in one of the availability zones in that region, meaning that if any of these availability zones goes down or any of these nodes goes down, I will be able to remain operational. So with this configuration, my YugabyteDB instance in the East can tolerate zone level outages with recovery point objective of 0, meaning no data loss, and with the recovery time objective measured in seconds, probably 3 seconds, 5 seconds. It depends on your network configuration and on how quickly an outage is going to be propagated to the application layer. Okay, now we can start an application that will be running some workload against these database nodes. Let's go to my Microsoft Azure portal. I will start my application on the following market order application virtual machine. It also runs in the United States East because I selected East as the primary region for my database deployment. Okay, jumping to the terminal. And first I will be connecting to this machine. I'm there. And here I have this sample application. It's called Market Orders application. What the application does, it connects to a remote service on the internet. It will be receiving mock market orders. It will be processing them and then storing them in YugabyteDB. The application is very straightforward. There is a configuration that I have already prepared. This configuration is here. Let's take a look at it. I'm going to use the YugabyteDB Smart Driver. This is an extended version of the standard PostgreSQL JDBC driver. What this driver does, it will connect to one of your nodes, and this is an IP address on one of those database nodes in the United States East. And the driver will connect to this node, and then it will learn the IP addresses of the other nodes that exist in your cluster. And once the driver knows all those addresses, it will be able to load, balance, read and write workloads across your entire cluster. Also, if any of these nodes goes down, guess what? The driver will be able to reconnect to the healthy nodes and your applications will remain operational. Another parameter that we have here is called data source additional endpoints. This one is used only when you open the very first connection with your database. If it happens that this node is not available for any reason, then the driver will try to open a connection to the cluster by using one of these IP addresses. And these IP addresses are private IP addresses of the other 2 nodes that I have in my cluster in the United States East. Sounds good? So this is the configuration. Now let's start our application. The application has started, it created the schema, and now it connected to the stream of data. It receives the market orders. And now you can see that, yeah, we successfully received those orders. We run some statistics, and the data is being stored in YugabyteDB. How do we check this? Let's go to YugabyteDB anywhere. And I want to connect to this node. Let me click on this node, and as long as this node is deployed in Azure, I can get its public IP address. And I can use PSQL or any other SQL tool to connect to my YugabyteDB instance. Using PSQL, that's the IP address of the node, the username is YugabyteDB, and the port number is 5433. We are in. You can see that's the data that was created. And we can also check the total number of trades from this connection. We can keep watching it. Cool. Now, before we test our multi-region setup and before we configure the asynchronous replication between our 2 standalone clusters, what I want to do, I want to simulate a zone level outage. Because I want to show you what's given for granted when you run a stretched cluster. If I stop any of these zones, then guess what? My cluster will remain operational. How can we emulate a zone level outage? Because we certainly cannot disrupt anything in the zone, but for instance, we can emulate that by stopping one of the nodes that runs in one of the availability zones. For instance, let's emulate the outage in the United States East, zone 1, by stopping the node that runs there. That's the virtual machine that runs this node, and all I need to do is to execute this stop command. All right. And I think that shortly, once I get to YugabyteDB anywhere, that's my cluster, you can see that this node is no longer reachable. It's stopped, but still the cluster is live. I have a consistent data set. There is no any data loss. And also my application keeps running. You don't see any disruption at all. However, do you remember this connection that we had using PSQL? PSQL was connected to that node and we stopped that node, meaning that we lost the connection. But my application used the smart driver of YugabyteDB. It also used a connection pool. And the driver automatically detected that some of the connections failed. And guess what? The driver and the connection pool reopened new connections to the nodes that are healthy. That's how you can tolerate zone level outages without any disruption to your application workloads. What I want to do next is let's bring this node back because I want us to explore the multi-region setup. We do this by starting back the virtual machine that runs an instance of that node. And I think that within a minute or less, we will get this node back to our cluster. And that node also will start serving and handling the user read and write workloads. Refreshing one more time. Excellent. The node is live, it's back, it just joined the cluster. And also it's already serving the read and write workloads. Okay. If you go back to the application, also no any impact, the application keeps running. All right, my friend, now let's go to our second cluster that is deployed in Azure, and that cluster is going to be used as a secondary. The name of this cluster is follows. It's the same cluster, but in the United States West. The cluster also has 3 nodes, and every node runs in one of the availability zones. This cluster also by definition can tolerate zone level outage. Let's try to connect to this cluster. Here is a list of all of the VMs that I used for this demo today. And as an example, I can connect to that cluster through this database node. Let's do PSQL. The host number is as follows. The username is YugabyteDB and the port is 5433. Connected. If you check the cluster right now, it doesn't have any data, it doesn't have any tables. And this is exactly what we are going to change next. We want to use it for our disaster recovery needs. Let's go back to the main cluster in the United States East. This one. And on that cluster, I go to the xCluster Disaster Recovery tab. And this is the place where I will enable this capability. Let's click Configure it. I need to select a replica cluster, a replica universe. It's easy. We have this market orders United States West cluster. During this setup and configuration, we need to take a backup of the database in the United States East. And that backup is going to be applied to our replica cluster in the West. I'm going to use Azure storage for my deployment today. That's the configuration that I also provided in YugabyteDB Anywhere. Then you can provide some of the replication like alerts. By default, the alert is 3 minutes, meaning that the YugabyteDB Anywhere will raise a red flag if you exceed this time. And we are ready to enable the disaster recovery. Excellent. The process is in progress, and you can see what's happening right now. The cluster in the United States East was selected as the primary. That was our expectation. And the cluster in the West is selected as a replica. And presently we are preparing the replica. What happens? we will take a full backup from our United States East cluster. We will apply that backup on the replica, and after that we will be streaming the changes in real time. If you take a look at the application, this whole process and setup takes place without any impact on your application workload. The application keeps receiving market orders, it's processing them and stores into the database cluster in the East. Alright, in a minute or so I think the setup will be completed and we will be able to go and test the failover. Yes, you can see that we are waiting for the DR, we are bootstrapping the cluster in the United States West. So soon we will be back and experiment with the switchover and failover. Congratulations, it said that the xCluster is fully enabled. This is our primary cluster, it's replicating the data, and the secondary cluster is receiving the data. Let me refresh the screen. Oh, I don't need to refresh it. The current replication lag is around 1 millisecond. And if you take a look at the chart, yeah, that's the data lag, is even below 1 millisecond. What it means that your cluster in the East, the primary one, goes down, you might lose up to 1 millisecond of changes. But it's important to know that even if you lose that data, your data set on the replica cluster will remain consistent at all times because the replication is transactional. Our replica cluster applies only those transactions that were fully replicated, but still this replication lag is very low, just 1 millisecond. Next, what do you want to do? I want to experiment with the failover, and the failover takes place when something unexpected happened. For instance, that's our primary cluster in the East, and now let's emulate a region level outage in the East and then perform the failover to the replica cluster in the West. How do we emulate an outage in the entire cloud region? It's very simple. Let's go back to my Azure portal, and here I will select all of the VMs that run in different availability zones in the United States East, and those VMs run my database nodes, and I will do this. I will stop them. Let me stop them. And if we jump back to YugabyteDB anywhere, let's go to the nodes tab, then pretty much soon we will see that all of those nodes are no longer reachable. Let's refresh the screen. Alright, all of the nodes are down. What happened to our application? Yeah, the application is no longer connected. The application cannot reestablish the connections because it was connected only to the nodes from the United States East. And that region right now is no longer operational. If we go to the xCluster disaster recovery, now we have to initiate the failover as soon as possible. So what we are doing, yeah, the xCluster DR reminds us that the potential data loss is around 1 millisecond of changes. I'm okay with that, and it asks me, do you want to switch to the following cluster in the West? Sure, I want. Let's do this. And right now we have this in progress. So this cluster that used to be the primary is marked as failed, and you can see that we are switching the primary role to the cluster in the West. So it should happen within a minute. Excellent, the failover was successfully completed. Right now it said that the cluster in the West became our primary. There is no any replication in progress. The replication is halted. Why? Because our cluster in the East is failed, but still we can restore our application workload. One thing that we would need to do is as follows. This is my connection to one of the nodes in the West, and you can see that application used the sequence, and that trade ID sequence was generating IDs for my trades. I would say that's not the best approach to generate the unique IDs, especially in distributed environment, but I'm using this sequence for the educational purposes. Why? Because if you take a look at the last value of this trade ID sequence, you'll see this number, and this number is not the latest one. Why? Because when you have that asynchronous replication between two standalone clusters, presently that asynchronous replication doesn't replicate the DDL changes or the changes to your sequences, which means that we need to perform the following operation manually on our cluster in the West. We need to find the maximum ID of the trade table, which was the latest trade that was inserted in the cluster. And then I'm altering the sequence, trade ID sequence. I'm restarting it with the number 5090. That's going to be the next ID. Excellent. Now, if we check the last value is as follows. How about we go back to our application instance and reconnect it to the cluster in the West. We will be using a different configuration in this YugabyteDB properties file. I have YugabyteDB West, the same configuration, identical one, but this time the application will be connecting to the database nodes that are in the West. That's the IP address of one of the nodes in the West. We go to the configuration here and I'm telling West, connect it successfully, and we keep inserting trades into our database. Wonderful. So the failover completed successfully. Now assume that our United States East region was restored. We want to bring back our failed cluster. First, we need to take all of these VMs and start them. Once those VMs are started, our database nodes will be launched and they will form a cluster once again. We can monitor this on the YugabyteDB Anywhere. If we go to the YugabyteDB Anywhere nodes tab, and shortly, I think also within a minute, we will see that the cluster in the east will be restarted. Let's just refresh the screen. All right, the first two nodes are up and running. They joined the cluster, and let's refresh one more time. Excellent, the entire cluster is now operational. We have 3 nodes and the state is back to normal. This is what I wanted. I can jump back to the xCluster disaster recovery and I want to repair the failed cluster. Let's repair the DR. We are going to use the United States East cluster that was just restarted as our replica. Let's initiate this repair. And during this procedure, what's going to happen? The xCluster DR, it will take a snapshot and backup of the data on our cluster in the West. And then that snapshot will be applied to our just restored cluster in the East. And once this operation is completed, the xCluster DR will enable the asynchronous replication from the West to the East. So this is the first step in bringing back our cluster in the East. Let's wait. I think that it will also take a minute. But in the meantime, if you keep looking at the application, no any disruption to the application is connected to the cluster in the West. Okay. It said that, yeah, the United States East cluster is being bootstrapped. Let's wait. Excellent, the xCluster disaster recovery is back to normal. To summarize, our cluster in the West is still the primary. The cluster in the East is now the replica. We are streaming the changes from the West to the East, and the replication lag is around 1 millisecond. However, now, how do I do the failback? How do I promote the United States East cluster to the primary? It's easy. You can use the switchover operation. Let's do this. When you do this switchover, you will achieve the recovery point objective of 0 because there will be no any data loss. You will stop your application workload, but you would need to stop it. So let's stop it now. You can certainly do it later throughout this process, but I don't want to forget this. And then I'm saying that, yes, I want to perform the switchover to my cluster in the East. The cluster in the East will become the primary. The switchover is in progress. And once this cluster in the East becomes the primary, guess what? The cluster in the West will become the replica one more time. and it will be receiving the changes from their new primary cluster. So the switchover in progress, and based on my experience also, it will be completed within a minute. Oh no, it completed within 30 seconds. Excellent. What can we do now? You remember that we used those sequences for ID generation, and that's a good lesson for us. Before I reconnect my application, I need to restart the IDs of my sequences. To do that, let me connect to one of these nodes, like for instance, to this node in the east. That is primary right now. I'm changing the IP address, connecting to the node in the east. So what we need to know the maximum ID of the latest trait that was inserted into the database, and then we use this ID to alter the next ID that will be generated by our sequence. We are using the restart with, and it's going to be 7594. Done. We are ready to restart our application. How do we do that? It's easy. We have this configuration, and this time the application will connect to the cluster in the east, how it was in the very beginning. Cool. The application is back to normal, and it keeps running. And that's it. Alright, thanks for watching this video to the end, my friend. Hope you enjoyed it and found useful. In this video, we explored how to achieve disaster recovery when you have two data centers, when you have the primary YugabyteDB cluster running in one data center or region, and when you have the secondary one. But also, in the description to this video, you will find a link to a technical talk that is coming soon, where I will be demonstrating more options for multi-region applications. So sign up and hope to see you there. Bye bye now.